Physics is one of the most fascinating branch of science. And if you are a physics lover, then you would have definitely heard about Erin Schrödinger, who is considered as one of the father of quantum mechanics and is also famously known for the Schrodinger equation. He was also awarded the Nobel Prize in Physics in 1933. He proposed many theories and experiments, and one of his most famously known experiment is known as the Schrodinger's cat experiment. But what do you know about this cat? And do it really exist? Well, stay tuned to Gateway to Knowledge to know why Schrodinger's cat can never die. It is often said that anyone who claims to understand quantum mechanics is either lying or delusional. In 1935, world-renowned physicist Erin Schrödinger proposed an experiment to demonstrate the true reality of all the things. The experiment came to be known as the Schrodinger's cat, but now the researchers have conducted the first ever real-world test of the Schrodinger's cat experiment. In this procedure, a cat is placed inside a chamber along with a sample of cesium-131, which is a radioactive isotope. A contraption within the test chamber will either kill the cat or spare the cat's life, depending on what that cesium isotope does. If the cesium undergoes radioactive decay, the cat will die. If not, then the cat will be live. The conditions of the experiment are so devised that the cat have an even 50-50 chance of survival. But according to the bizarre laws of the quantum world, which is actually the world of atoms, nothing is real unless it is being observed. In the absence of an observer, anything and everything that can happen does happen, all at once, all jumbled together into an coexistent meta state. And so, once the test chamber is sealed and its content can no longer be observed, the laws of quantum mechanics should take over. The cesium isotope simultaneously does and does not decay. The killing apparatus simultaneously has and has not been triggered. Similarly, the cat is live or it may be dead. And so the situation should remain until the scientists reopen the test chamber and observe its content. The researchers originally intended to run the experiment only a dozen times, but the test results were so surprising and so confusing that additional tests were needed. In total, 63 cats were put through the experiment, and to the astonishment of everyone, all the 63 cats survived. But how was that possible? We are unable to explain it. In statistical analysis, half of the cats should have died and half should have survived. But the survival rate was 100%, and we didn't lose one cat, not even a single one. Several hypotheses have been proposed to explain these surprising results. One possibility is being referred to as the 9-life hypothesis. Since cats are said to have 9 lives, perhaps whenever a cat dies in the test chamber, it immediately resecures itself. Although this notion was initially suggested as a joke, the researchers latched on this idea and even proposed a mechanism that may explain how unobserved cats are able to continuously revive themselves. Even in 1930s, it was pointed out that a cat is perfectly capable of observing itself. But has it not occurred to anyone that only living cats are able to make such observations? So as long as Schrodinger's cat remains alive, it observes itself as living. The moment it dies, there is no longer an observer present. The laws of quantum mechanics again comes into play. The cesium has once again simultaneously decayed and it may not be decayed. And thus the cat is once again simultaneously dead or it may not be dead. But the living version of the cat is capable of observing itself to be alive, causing the superposition to collapse. Thus, the Schrodinger's cat can never die. So we can say that the 9-life hypothesis should now be accurately called as the infinite life hypothesis, as there is no theoretical limit to how many times a cat would be able to revive itself in this manner. But however, the Schrodinger's cat experiment have profound implications for our understanding of quantum mechanics and also to express the reality of nature itself. Hope you find it useful. If you did, then do like and subscribe to my channel.